Over the past few weeks, I've begun a project working on a fairly beefy 8-bit breadboard CPU, building on what I learned from my CHUMP project and using an architecture which I've designed myself. The first part of it, the program counter, is now finished and working. For now, I'm using a simple 555 timer circuit as my clock with a 100 kiloohm potentiometer in place to control the speed. I may end up expanding this clock as I develop the CPU so that I can manually advance it for debugging, or so that I can clock conditionally, both of which were functions present in the CHUMP clock. The program counter itself is made up of 161 chips, that's these four, which are just TTL binary counters, which are chainable and one of the many parts I'll be reusing from CHUMP. These were my program counter in CHUMP as well. As you can see, there are 4 of them chained together, which makes a 16-bit counter, and that's because this CPU design features a 16-bit address bus, which is this bus over here. It's still an 8-bit CPU, as data is moved around the CPU in bytes, but the jump in usefulness from 256 addresses to 64,000 addresses is hard to understate. There are also 2 573 registers between the counter and bus, which are by far the most versatile and useful chip in this whole design. They double as transparent registers, which sample on a high signal and latch on a low, and buffers, because their outputs are also able to be set to a high impedance mode. Since my design is centered around 2 main buses, the address bus and the data bus, this is super useful because I can put data onto the bus and take it off without conflicts, all with this one chip. Finally, I've started wiring up my RAM to the address bus as well as my boot ROM. This is a Princeton architecture, meaning that instructions and data are not differentiated between on a hardware level, and instead they're all stored here in RAM. When this CPU is complete, I want it to be able to load in a program from external storage from an I/O port and run it, which is the job of the boot ROM here. It's going to hold a small program that just tells the CPU how to load a program into RAM from external memory. Also, although I have 64 kilobytes of address space, since I have a 16-bit address bus, I'm only using a 32 kilobyte RAM for the simple reason that it's the largest parallel RAM chip I could find online, and I think if I went any larger, I would have had to redesign for serial format RAM. Other than simulating part of the CPU, which I might show off in a later video, that's about all I've done so far, and I'll probably make my next progress update when I finish the memory modules and add the data bus on. And that's what the whole thing looks like right now.